This is David Tana Costanza coming to you from my home office in Portland, Oregon. Lately, we've been making it possible to write SAW proofs using Python, and it's just about ready for a demo. SAW, the Software Analysis Workbench, is one of Galois's verification tools. SAW uses a combination of symbolic execution, SMT-assisted reasoning, and interactive theorem proving to reason about programs written in imperative languages, like C, C++, and Java. Traditionally, SAW was configured using a custom DSL called SAWscript. To improve integration with other tools, we've been working on enabling any programming language to control SAW through a JSON RPC API. Our initial target is Python. This C program contains two functions. One swaps the targets of two pointers by assigning to an intermediate variable, and the other swaps them without the intermediate variable using a trick involving XOR. This specification says what it means to swap two values. The precondition declares two unknown values, each of which has a pointer that points at it. When called, the function should be provided with X pointer and Y pointer as arguments. After the function has returned, each pointer points to the value that the other one had prior to the function call. In other words, they've been swapped. Verification fails. Let's go fix the C program. The problem comes from line 47, it's XOR swap. Here's the problem. On line 11, that B should have been an A. Rerunning the verification script shows that we fixed the bug. Controlling SAW from an existing language gives users access to a rich library ecosystem. The left side of the screen shows the specification for the Salsa 20 stream cipher as a compositional verification task, where the results of earlier verification tasks are fed into later tasks. The right side of the screen shows a visualization of the dependencies between these verification tasks. While verification is ongoing, the visualization lets the user keep track of progress. This is made possible by libraries written in Python and Rust, but you can use any language you want. We wrote this visualization, but you can write whatever tools work for you. Introducing a mistake demonstrates some of the value of visualizations like this. For this visualization, we set Python to log verification failures and continue, rather than terminating at the first one, so the rest of the tasks continue to run. This kind of flexibility to do things not anticipated by the original developers is another benefit of an open, language-agnostic API. Thanks for watching. If you'd like to learn more about SAW, please visit saw.galois.com.